Hello everyone and welcome to 4D Systems Introduction to NX Additive Manufacturing. Today what we're going to do is set up a build tray for a set of gripper fingers on our training robot and actually execute that print on a 3D printer and show you the whole process here. So first we'll take a look at the parts we're going to print here. So we have a training robot at 4D Systems. We have robotic integrators as well. And on this training robot, we have gripper fingers. So, for instance, we have these manufactured in aluminum right now, but to save cost, or for instance, if the students on this training robot get a little too aggressive with these grippers and we need to replace them, it might be something that we can look into 3D printing so we can have replaceable parts on hand as needed. So we'll take a look at these gripper fingers a little more in close-up depth here. So there are some features in here that were made for manufacturing with aluminum. These recesses here to allow for relief cuts, and for also this gripper indent for the pointer. That might be something that's challenging to 3D print. So we'll take a look at that in the additive manufacturing space and maybe make some modifications to make it easier to print. So first thing we're going to do is we're going to go ahead and open up our print bed. So this is for our specific printer. We're going to be doing this with a plastic printer because that's what we have on hand. And that plastic printer is called a Lulzbot TAS 5. And in this case, we have our properties set up already in advance. So this is sort of a template for us, but you can also set up templates for any of your 3D printers. So in this case, we have all our height sets, our origins, our tray heights, and all that set up properly in this print bed. So the first thing we're going to do is start adding some parts. So we're going to add our gripper fingers here. So we're going to go ahead and add our gripper fingers. In this case, to show off some of the nesting capabilities, I'm going to go ahead and add about, let's say, 50 parts. So this is a case where we're running production. We want to fit as many parts as possible. We're going to add more than potentially might fit in this build tray and see what happens here. We're going to go ahead and place those 50 parts down. We're not going to constrain them in any specific way right now. And we're going to go to automatic nesting. So this is one of the core features of NX Additive. In the case of using something like a powder bed or like a multi-jet fusion, you can do 3D automatic nesting so you can maximize your build volume to maximize your production output. You can also do 2D nesting as well if you have a 3D printer that can't do the stacking of the parts like with those powder beds. In this case, I want to show off the 3D because it is something very interesting to look at. So to run this 3D nesting, we're going to go ahead and set our parameters. We want 0.5 millimeter distance between parts. We're fine with this wall distance and the Z level. We want them to be free, but you can also fix these in specific orientation. So if you want, for instance, you know that you're going to get the least amount of distortion in a specific orientation, you can set that orientation and then you could nest using that specific orientation throughout the entire build tray. In this case, we want to show it free, so this will stack parts however it sees fit. We're going to go ahead and optimize our height. We're going to target 50% density. We're going to stop after a minute, and we'll go ahead and show our progress. And this will just run for 1 minute. And here you can see it attempting all these nesting options. It'll do a little bit of progress here. It'll show you the results, and then after however long you select it, so obviously you give it more time, it'll do a better optimization. In this case, it's just fitting all the parts in there. It's going to go ahead and now try to move them around for approximately 1 minute, and it'll show you the optimum result for what your selections were. So you'll see on the bottom, the nested density right now is about 22, so it's trying to work towards that target and get as close as possible, and then it'll stop after 1 minute. So this is great, again, for running production if you want to fit a whole assembly, right? So you can throw a whole assembly into the build tray, and then move it around until it all fits in there so you can build everything at once. So you can see here, there's not a single part here that's going to be touching necessarily, right? They're going to be at least at 0.5 millimeter apart, and they're stacked in a free orientation so they can go whatever way they'd like here. So in this case, I'm going to actually clear these out. So in this case, we're going to add 2 parts because that's what we want to print 2 of these things. And we're going to show a little bit of the prep that we need to do for these two parts here. So I'll set up this build tray manually. So you can see here it works similarly to any type of assembly, kind of. You have individual components you can move around and place how you see fit. In this case, I'm going to try to nest these parts as close as possible so we can minimize our build time here. Okay, and then we're going to go ahead and start constraining these parts as well. So in this case, I'm going to go ahead and bond these two parts together so they move in orientation together. And then I'm going to go ahead and touch these parts off to the top of the build tray. And we need to be able to select the build tray. That's a great thing here too, is that you can select the build tray geometry to be selected or not. So if you need to work on the parts, you can shut that off. And then when you need to select the build tray so you can place the parts down, you can go ahead and do that as well. So we're going to go ahead and select our face that we'd like. And we're going to go ahead and select the build tray volume here. And you can see that it will then stick the parts down. So we're good with this. I'm fine with this orientation. Now so that's how you can manually space these parts without using assembly constraints. And you can set distances between parts and constrain them together and add different parts in here as well. Let's go ahead and start working with the support structures, right? So in this case, I want to create some supports. I want to create them on this part right here. And in this case, there's going to be a few spots that need support here. So we know that anything that has a vertical overhangs needs support. So in this case, this area right here might need a support, and then this area inside might need a support, as well as this interior V block. So we're going to go ahead and create a manual block support here. Okay, you can see it'll create supports, and then you can go ahead and modify these supports here and edit these parameters. So you can select pretty much everything you like, whatever, if you like the teeth up here, if you want to keep those off, if you want to change the way that the cross section is, from a diagonal to a diamond, something like that, you can change all those parameters here, and then you could copy those parameters and apply them to all your blocks as well. In this case, I got to make one more support, so we're going to support that area above the holes because we're going to keep those features. So we're going to select this part now, select our two faces, and there you go. The supports are automatically created, and there they are. In this case, I decide now that I don't want to add support structures for these two features that are going to be kind of unprintable here. So this is the great advantage here of NX. If you were in any other type of slicer software or print preparation software, you'd have to go back to your design software, make those changes, re-export to an STL file, bring it back into your slicer structure, and then you're going to have to potentially rebuild all your supports you made. In this case, I want to change the structure of this part in a way that makes it easier to print. So I want this feature to be suppressed, extrude form. So I'm going to go ahead into the part and we're going to suppress this feature so I can keep it around in case I still want to use this in the metal sense here. But you can see now it's just going to be a gripper finger. So you're going to have that cut out there. We're also going to want to get rid of the overhang here. So I already actually pre-made a chamfer here, but it's relatively easy to make this. So it's a simple one chamfer operation, and I made an overhang that the printer can handle. It's about 30 degrees. Most printers can do up to 45 degrees without support, depending on what your printer settings are. So in this case, this part is now much easier to print. So all I have to do is save the part here. I can even close it out. And you can see these parts have already been updated. The one thing is that the support structure needs to be re-updated. Just go ahead and regenerate the supports and regenerate everything. And here you can see that there's no timestamps here. So this part, in this case, is ready to print. So This way it's just very easy. So we don't have to do a bunch of file export. You're going to have a lot less potential for error when you're exporting between the two file types, right? So we don't have to re-export it as an STL and then have to re-import to different software. We can do it all from NX. That's the key advantage here, is the integrated solution between design and preparation. So now we're going to go ahead and talk about build processes real quick. So like I said, we can do a 3MF or STL right out of the box. In this case, because we're doing a simple FDM printer, I can export an STL right to it. However, this also works with materialized build processors. So if you already have materialized for your 3D printing solution, it'll automatically pick up on all those printers, and you can use this 3D printer tool tab here to manage your 3D printers, to edit your build strategies, to configure your printers, and to straight up print. So if you're connected to a network that has the 3D printers on it, you can send it right to the printer. It'll queue up and be ready to go. There's also options to use HP Multi-Jet Fusion products with build processors out of the box. So if you have a Multi-Jet Fusion product, NX has partnered with them to make build processors that work straight out of the box. So again, if you have that option, you go ahead and you will send it straight to your printer. Basically, it already has it all built out for you. So there's great options, either if you want to use an STL and then do your own slicing, or if you already have materialized or would like to purchase material licensing. I think we have a deal with them that we can sell materialized licenses as well in partnership with this additive product. So in that way, you already have an established product materialized, and then you have this additive manufacturing space within NX that allows for easy design and build changes. It has the 3D nesting. It has your assembly style part preparation, which is very familiar to people that use NX. And then it also has the support structure building, which has become more and more powerful and has customizability that a lot of the 3D printer slicing software might not have. They have presets that might work, but if you really need the precise support structure, you can find it with this additive space. So we're going to go ahead and print this part. It's going to output to an STL file. So yeah, let's go ahead and print this thing, and I'll show you the video of it printing and what our final result looks like. All right, so the part got completed. Here you can see I'm removing the support material with a screwdriver. It's pretty simple. That was all generated through NX. No special software needed. It was all just in the STL file itself. So you can see how easy it was to remove, and the part came out great. The holes came out very clean. There was a little bit of errors on the top there, DLAM on the bottom. That was just due to the room temperature I was in. I actually had to set up in my workshop in my house because of the coronavirus. So it was a little cold down there. But other than that, the part came out great, and looking forward to taking these to the shop and test mounting them.